Very mindful, very demure. Very mindful, very demure.
Shut your very demure gluten allergy-inducing face.
All right, everyone, welcome back. Ready for another deep dive?
Absolutely, let's do it.
Awesome. So today we're going to tackle something called carbon dioxide removal, or CDR.
CDR, yeah.
And, well, we got to figure out why it's so important for dealing with this whole climate change thing. I mean, let's be real. Climate change isn't some problem for our grandkids to deal with.
Right.
It's happening right now.
Yeah.
Crazy heat waves, wildfires going nuts, hurricanes are like superstorms now. It's pretty intense out there, wouldn't you say?
Definitely. And, there's this CDR one-pager report from the National Academy of Sciences.
Yeah.
And they really emphasize this point, like the effects of climate change. We're seeing them globally already. It's not just a future thing.
Totally. And it's not like we can just hit a rewind button on this, right?
Exactly.
So what do we do? How do we even start to handle this mess?
Yeah, good question.
Well, picture a bathtub.
Okay, yeah.
It's overflowing.
Oh, no.
Water's going everywhere. What's the first thing you do?
Yeah, turn off the tap, right.
Yeah.
Stop the water from coming in.
Exactly. That's like decarbonization in the climate world.
Ah.
Okay, cut those emissions, transition to clean energy, ditch those fossil fuels.
Or the tap, yeah.
Exactly.
Right.
But hold on, we've still got water all over the floor, right? We can't just ignore that.
You got to clean it up.
We need a mop.
Yeah, the mop.
And that's where CDR comes in.
Okay, I see where you're going with this.
It's about actively getting that CO2, the stuff that's already in our atmosphere, out of there.
I love that analogy. Decarbonization's turning off the tap and CDR's mopping up the mess.
Right. It really shows why we need both. So let's dive into this mop, this CDR. What is it, really?
Well, the CDR one-pager, they define it pretty clearly. It's about all these different strategies. Some are natural, some are high-tech, and they all work to pull CO2 right out of the atmosphere.
Interesting.
We're not just slowing down emissions here. We're going a step further, trying to reverse the buildup of CO2 that's causing all these climate problems.
So it's more than just planting trees, which is what a lot of people think of when they hear carbon removal, right?
Right.
Looking at this one-pager, I was surprised to see so many different approaches. They have things like direct air capture systems,
Right.
bioenergy with carbon capture and storage. That sounds pretty complicated.
Yeah, some of it gets pretty high-tech.
It does.
But the thing is, the IPCC, they're like the leading authority on climate science.
Right.
And they say that if we want to limit warming to 1.5 degrees Celsius, which is like the goal to avoid the worst effects, most of the ways to do that rely on doing CDR on a massive scale.
Wow. So even if we cut way back on emissions, like drastically, we still need CDR to really get a handle on this climate situation.
Exactly. And we're talking billions of tons of CO2 that need to be removed every year by the middle of the century. Billions, according to the National Academy of Sciences. And that's why it's so crucial that we start investing in scaling up all kinds of CDR, and we got to start now.
Wow, billions of tons. That's just mind-blowing. It really hits home how seriously we need to take this and right away, right?
Absolutely. The urgency is real. It really is. And it's not just about planting trees like a lot of people think.
Right.
This CDR one-pager, they highlight all kinds of different approaches from natural solutions to some pretty wild technologies.
Yeah, some of that stuff sounds like it's straight out of a sci-fi movie.
I know, right?
Like giant machines sucking CO2 right out of the air.
Yeah.
Is that even possible?
It is. There are companies already doing this, like Climeworks in Iceland.
Really?
Yeah, they've got this plant called Orca, and it can capture 4,000 tons of CO2 every year directly from the atmosphere.
Wait, so this isn't just like a theory or something? There are actual plants up and running doing this.
Yeah, it's happening.
That's amazing.
It is, but the technology is still pretty pricey. Like that Orca plant, it costs something like $600 to $800 per ton of CO2 captured.
Wow, that's expensive.
Yeah.
I guess that's going to be one of the big challenges, right?
Yeah.
Making it more affordable so we can actually scale it up.
Exactly. Cost is a big hurdle, but there are other approaches too, like BECCS. Have you heard of that one?
BECCS?
Yeah, it stands for Bioenergy with Carbon Capture and Storage.
Okay.
And this one's really interesting because it has the potential to be what they call carbon negative.
Carbon negative.
Oh.
That's a new one for me.
So think about it, this plants, they absorb CO2 when they grow.
Right. Basic photosynthesis.
Exactly. So if we grow a bunch of plants, like biomass specifically to make energy, and then we capture the CO2 that gets released when we burn it, we're actually taking more CO2 out of the atmosphere than we're putting in.
So we're removing carbon twice.
Pretty much. But even with BECCS, there are challenges.
Like what?
Well, you need a lot of land to grow all that biomass.
Ah, yeah, I see the problem.
Yeah, and that could end up competing with other things like growing food or preserving natural ecosystems.
Right, we can't just turn the whole planet into a giant biomass farm.
Exactly. It's all about finding the right balance.
So it seems like with all these approaches, there are always trade-offs.
There often are, and that's why it's so important to invest in research and development for all kinds of CDR.
Makes sense.
We need to figure out which ones work best in different situations and how to minimize any downsides.
Speaking of different approaches, this one-pager mentions something called ocean alkalinity enhancement.
Oh, yeah.
That sounds intense.
It's basically adding certain minerals to the ocean to help it absorb more CO2.
Wow.
It's still in the early research phases, but it has the potential to remove CO2 on a huge scale.
Okay, now we're talking
Right.
planetary scale solutions.
Exactly,
But it also sounds kind of risky messing with the ocean's chemistry like that.
yeah, that's why research and careful consideration of the potential consequences are so important.
We don't want to solve one problem and create a new one.
Right, exactly.
It seems like this whole CDR thing is like a whole new frontier of scientific exploration.
It really is.
It's exciting, but also kind of daunting. We're talking about intentionally manipulating Earth's systems here.
That's right. And that brings up some big questions. If we can remove billions of tons of CO2 from the atmosphere every year, what does that mean ethically?
Yeah.
Are we messing with something we shouldn't be?
Who gets to decide how much CO2 we remove?
Yeah.
And from where? What about unintended consequences?
Exactly. Those are all crucial questions that we need to think about. CDR isn't just a technology challenge, it's a social, ethical, and political one, too.
And probably an economic one, too. All of this is going to cost a lot of money.
Absolutely. The National Academy of Sciences, they estimate that we need to be removing billions of tons of CO2 every year by the middle of the century, and that's not going to be cheap.
So we've got this monumental challenge, this urgent need to scale up CDR,
We do.
but it also feels like an opportunity to do things differently, to create a more sustainable future.
Yeah.
It's kind of inspiring in a way, don't you think?
Yeah. It is. It's a reminder that we have the power to shape our future, not just react to it.
Well said. You've definitely given me a lot to think about. So what happens next? Where do we go from here?
Right.
That is the big question. Where do we go from here?
Well, the first thing to remember, and the CDR one-pager really stresses this, is that CDR, it's not a free pass to keep polluting like we are now.
Right. It's not an excuse to ignore cutting emissions.
Exactly. It's not a replacement for decarbonization.
Okay, so decarbonization is still priority number one.
Absolutely. We still need to transition to clean energy, electrify transportation, decarbonize industries, all of that.
So it's like attacking the problem from both sides, turning off the tap and cleaning up the spill, to go back to our bathtub analogy.
Exactly. We need both. And that means investing in a whole range of CDR approaches, natural and technological.
Like diversifying our climate portfolio.
Right, not putting all our eggs in one basket. And that leads to the next step, scaling up.
Going up.
We need to move beyond just pilot projects and small-scale research. We got to start deploying these technologies in a big way.
But as we talked about earlier, scaling up comes with its own challenges,
Yeah.
right? The costs, the logistics, it's not simple.
Definitely.
And how do we even make sure that these projects are done in a way that's safe and equitable and actually effective?
That's where governance comes in. We need strong frameworks to make sure CDR is done responsibly and transparently.
So it's not just about the technology itself, it's about the whole social and political context.
Exactly. CDR is not a magic bullet. It's a tool. And like any tool, it can be used for good or bad. We need to be careful and thoughtful about how we use it and aware of the potential risks and benefits.
This has been a really eye-opening deep dive. It's clear that CDR is complex. There's no doubt about that.
It is.
But it's also incredibly important. I mean, it feels like we're at a crucial point here, like we have a real chance to make a difference. What do you think?
I completely agree. We're at a crossroads. And the choices we make now, they're going to have a huge impact on the future. But I'm optimistic. I think we have the ingenuity, the drive, the will to tackle this challenge.
I hope so. This whole conversation has really driven home the fact that climate change, it's not just some abstract idea. It's impacting people's lives right now. And it's on us to do something about it.
Couldn't have said it better myself.
So for everyone listening, we hope this deep dive has helped you understand CDR better and why it's so vital in the fight against climate change. The science is clear, the urgency is real, and the time to act is now.
We're out of time, but be sure to check the link in the bio for more info and special videos from us, Avocado and
Toast. Good job, everyone. Another stellar performance by the whole team. Couldn't have done it without each and every one of you.
I swear, Toast, your relentless positivity is,
Refreshing?
Enraging.